Well, a phrase you might run into in the summertime, especially in the Midwest, Great Plains, is a backdoor cool front. What does that mean? Well, what's a front door cool front? Let's start with that. A typical cool front is what we're really talking about, and on a weather map, I might typically find a cool front like this, draped across the plains and moving southeast. So if it's moving into the warm air, I would draw the little triangles pointing in the direction of the frontal movement. So it would be like this. So this would be a typical frontal position. Well, let's take a look at some conditions here in the example I'm going to use. Here's the satellite. Here's some temperatures. Well, let's find the front, and the temperatures are going to peg it for us, and clouds will help a little. But roughly, that front lies through here. Warm air is to the south, so I'll draw the little triangles again, pointing in the direction of the movement. Now, here's what makes this front different. This front is actually going to come in from the back door instead of the front door. So instead of from the northwest, this front will actually come in from the northeast or even the east for some people. So it goes like that. So it's just the opposite of what you would expect. So what allows this to happen? Let me turn off the temperatures and turn on the pressure systems this morning. And you'll see here we have a high pressure system located up here in Wisconsin. And the winds are flowing around that like that. So again, the frontal position is pretty easy to peg right in through there. And the wind shift helps in this case. So the high is going to drive this cool air. But where is the high going, and what are the steering currents like in the upper atmosphere? That's the real key to figuring this out. So let me get rid of that. And I'm going to replace surface conditions with conditions at about 500 millibars up in the atmosphere. That's roughly about 18,000 feet up. And if you take a look at that, and this is a typical summertime pattern, there's a big high pressure ridge aloft out over the Great Plains and flow out of the northwest at this level over the Great Lakes and part of the Midwest. So what's going to happen is this flow sort of indirectly supports the front. So in other words, if you're looking in the upper atmosphere here over St. Louis, the winds are almost out of due north. Over Little Rock, they actually turn to the northeast. So anything that's coming around the periphery of this high is going to tend to kind of go like that. And that includes surface fronts, which are driven by the upper atmosphere to a certain extent. And if I go at some intermediate level, let's say about 5,000 feet up, and I draw the same thing in, here you can see the winds are kind of pushing that front from Illinois southward into Missouri and then eventually southwestward into Missouri and Arkansas. So it's a backdoor cool front. They typically do not do much in terms of precipitation because the air is usually dry because of the northwest flow around that big ridge aloft, and they typically only cool way deep into where the front's gone through, and a lot of times they don't move through at all, and they'll leave large temperature differences wherever they happen to hold up until usually the ridge of high pressure builds back and destroys the front. But there's a little quick kind of primer on a backdoor cool front.